do is we will look at source code of Perplexica, which is an open source alternative to Perplexity AI. So if you have been following large language model and generative AI ecosystem, you will know that there is an organization called Perplexity, which is trying to build a better search engine, a search engine that uses large language model to generate responses. So I think most of the people who have used ChatGPT are also aware about Perplexity, and it's a good search engine. You can ask questions like healthiest cooking oils. What it will do is, rather than only relying on the knowledge of the model, which is the parameterized knowledge, it will also search the web for you, and the answer that it will generate will have references to that. So like olive oil, it will also say the references, like this is the link that mentions that about olive oil or some other oils. And you can also look at all these sources as well. So one of the biggest problem of chat gpt or generative AI is hallucination. So Perplexity tries to solve that by first searching the web for the right links and then building the answers from it. So the open source project Perplexica is trying to build an open source version of that. And I thought, let me look at the source code of it. Let me try to understand what it does. Let me try to understand what the magic is. And again, it helps me in my day-to-day work. I'm also building solutions using large language models and generative AI. So knowing how open source projects work always help in my work. So let's get started. So what I have done is I have inputted this project in IntelliJ. So this is not IntelliJ, it's a PyCharm, which is the Python version of it, but it has a good support for Node. So the project, if you look at it, it's mainly a TypeScript project. So they have two main folders here. One is the SRC, which has the backend code. There's a second folder called UI, which is the Next.js React application. We will mainly focus on the SRC folder, which is the backend, and most of the logic is there. So most of the things that are happening behind the scenes are in the SRC directory. So the way I typically try to understand code bases is that I first try to look at packages or whichever the build configuration file is. I try to see what tools they are using, what open source framework they are using, just to build some mental model of these things. So as you can see, this is using LangChain. LangChain is a very popular open source orchestration tool that makes calls to the large language models and provide a lot of utilities around that. So they are using, since this is a open source project, they are not tightly coupled with OpenAI. So you can use Anthropic or OpenAI. You can also work with Olama based model as well. So if you go down and look at the README, I think you will also find that it can also work with Olama. So you can work with multiple large language models. So that's one thing that we are aware of, that if we have to understand the source code of it, we have to know a bit about LangChain. Apart from that, you will find that they are using SQLite as the database. So they are using some sort of an, I think better SQLite will be some sort of an ORM that they are using. So if I just search, I don't know, to be honest, what better SQLite is. So let's just do a Google search of it, or why not do a Perplexity search of it. So let's just click here. Let's say better SQLite 3. Let's see what it gives. So you will see there is an npm package that it gives. It will say it's a high performance library designed for SQLite and Node.js. It will talk about the key features. Again, the good part that it is giving you references to both the uh, npm packages or the links. It was also referring to the YouTube videos probably, which might have more information. Again, it is talking about that. So it's an npm package for working with the SQLite database. So all the things that they have to store, they are storing in SQLite database. And I think Drizzle is the ORM that they are using, ORM wrapper over SQLite, better SQLite API. So they are using Express, which is again a web framework in the Node ecosystem. Uh, PDF parse for parsing the PDFs. I think Winston is the, I guess, a logging library. So we can quickly check it up. Let's just say Winston Node.js. Oh, Node.js, my bad. Again, you can see that's a logging library. So fine. So we know what it is. Zord, I think, allows you to create better types in it. You can also add the validation logic. It is again another open source Node package for that. Again, if you want, you probably can search using your favorite ID. So the TypeScript for schema declaration and validation library. That's what it is. WS is the WebSocket library. So I just try to look at just to understand what this library or tool or framework, whatever I'm looking at, is using. Again, Axios is the library to connect with to make HTTP calls. So that what it is. They also have a compute cosine similarity. I'm assuming that will be for comparing test, calculating the cosine similarity value of I think embeddings, and then doing the comparison over multiple embeddings. Uh, so that what it is. So more or less these are the libraries that they're using. Again, they have different script that they've specified, how to run it in dev mode, how to do a push to database. Again, everybody can look at these things themselves, but more or less this is what it the package JSON looks like. One more thing that I'd always try to look at least when I'm working with the web application like this, is how easy I can get started with. And I see that they have a Docker Compose .yaml, and they also specify in the README, if I look at it, as the Docker Compose setup. The installation, which they also recommend, you should use Docker, and you just have to do a Docker Compose up -t. You have to set the OpenAI key in your config.toml file. That's what you will have to do. And let's just do the Docker Compose up -t right now. Let's just copy and run it. Right now, nothing should be running, but I have images pulled. I've already pulled down the images, so it should be ready. It should get started very fast. So now we have things running. Docker Compose PS. So now I have three things running on my machine. One is the front end. The second is the backend, which is the Express API. And this is the next to React front end. And one thing that you will see is there's something called SearxNG. So what it is a let's just go to the repository of it. It's a meta search engine, so it basically makes calls to the search engine on your behalf. It acts as a federated search engine, so you can define which engines you want to use, whether you want to use Google, you want to use Bing. Again, not just search engine, you can also define search engine as YouTube, you can also define search engine Reddit, so it can do the searches for you on your behalf, and you don't get tracked or profiled using it. And this is what it uses to make a Google search. So if you have to build something like Perplexity, you will have to make a web search call. Right now in this framework, I don't know what Perplexity uses, but the Perplexica, which is the source code of open source tool that we are looking at, it uses something called SearxNG to do that. Again, probably someday we will also look at the source code of this project as well, but right now we will focus on the Perplexica. Now let's move ahead. Okay, so now the tool is up and running. It is running on port 3001. So we can try that. Let's just see. I don't see it running. Okay, the front end is running in 3000. So let me just do that. The back end was 3001. So as you can see, they don't have any authentication implemented right now, but the UI more or less look like Perplexity. So if I click if I open a new chat here, probably you will see that what will you discover? They are saying the search beacons here, but they also have. So if you look at the Perplexity, you will see there's something called the focus mode. So you can use a web academic, which will go to the archive papers, math, probably use some Wolfram or some other tool, writing specific to writing tool, video, social. Now they also have something similar. So they also have all academic, writing, Wolfram Alpha, YouTube, Reddit. And so they also have similar modes. They also give you a way to define whether you want the answer faster or whether you want a answer in a balanced manner. So there they try to do the cosine similarity of the query along with the results that they retrieve from the search engine, and then do the ranking of that. And they are also trying to build another mode called the quality. And what I will do is I will quickly open the network tab as well so that we can see what is happening. And from there, we will go to the code. Now, let's ask the same question that we asked this, which was probably better SQLite 3. Fine. So if I go in here, and this is my Perplexica instance running, and I just ask better SQLite 3. And let's look at the network tab right now, and let's make a call. Uh, So you will see that it is a bit slow right now, at least on my machine. Again, it does a Google search using SearxNG, and then it basically generated the answer using the content that it pulled from the web search engine. And answer looks good. So it is also referring uh, to the Better SQLite npm package, and it is referring to Stack Overflow question. So you will see that very similar to what we saw in the Perplexity UI. Answer, again, because of the model and few other things, the answer generation will be different, or at least the response structure will be different, but more or less the functionality is the same. Again, they don't do search images by default. I think if I just do search images right now, then they will make a call and probably find, like, this is the video that we found when we look at the Perplexity as well. So this was, I think, if I again do this again, node SQLite 3, this was the image, or this was the video that they were talking in this Perplexity.ai, the same thing that they are referring here as well. So you will see that the quality is more or less the same. Now let's try to see what happened. Now I like to see whatever network calls happened, like the API calls that they have made. Now, if we just look at these network calls, you will see that one of the network calls that they made is for the suggestions API, which is /API/suggestions, a post endpoint call that they made. And this is to build this next questions that somebody might want to ask. So Perplexity generate the next questions for you as well. So if I go back here, you will see that it generate how does Better SQLite handle large data sets compared to SQLite. Uh, Again, how does, you will see that it talks about how does SQLite handle memory management compared to, again, depending on the context, it basically generated the suggestion. So that is one of the APIs that it called, but it does not talk about the chat API. The reason for that is it does not make a HTTP REST API call for that. It uses a WebSocket connection for that. And right now I don't see any call, so let's just make another call here, like what, and let's see if we can see the WebSocket connection call. For some reason I'm not seeing the WebSocket call right now. Let's just see. Let's just refresh the page and make a call again. So if I just right now, nothing is happening here. We are not seeing the WebSocket call. So let's just do a refresh of this. Now, as you can see, this is the call that happens. So whenever, because I think I opened it late, so the WebSocket connection was already made as soon as I create a new chat. Now, if I again do Better SQLite 3, you will see that it opens it has already opened the WebSocket connection to the server, and using the WebSocket, the server is pushing the information to the client, and all the chats happen over a WebSocket connection. This is different from the way ChatGPT works. In ChatGPT, you make a specific API call for that, and it basically just do a response streaming. Now, if I look at the payload of this, or the messages that are being sent, the first message is the message that we just sent, which is Better SQLite 3. So this is the first message that we sent, which is the, it generated a chat ID for it, and after that the content is a Better SQLite 3. You will also see that it also sent the optimization mode as speed, because we are not caring about we are only caring about the response, the speed right now, not too much about the quality. So optimization by default is speed. The type is a message that we are sending. The focused mode is the web search, because it is doing a web search here, and we can change the mode as well. And let's assume now we make another call, or make the call, ask a follow-up question. How does Better SQLite handle large data set efficiently? And this is the same question that Perplexity also generated. How does Better SQLite handle large? So more or less you will see that they both are ending up generating similar next questions as well. So let's ask this question again. This is also happening over the WebSocket connection that we have, and we will see that so these are all the messages that are pushed from the server, and client is uh, rendering them. Right. Now, if we look at somewhere, you will see that we will see our follow-up question, which is how does better SQLite handle large data set efficiently? Fine. And after that, these are all the responses that we got. And again, as you can see, it first returns the sources and then the messages, which are individual tokens that are being returned from the backend. So now what we know is the main magic is happening in a WebSocket endpoint that might be there, a chat WebSocket endpoint. Now let's go in here and try to figure out where that is. As I said, UI is mainly for the UI code, so that is what we are not interested right now. What we are interested is in this SRC. Now this is an Express application which has a app.ts, which is the entry point of the application. Now you can see that this is basically Express configuration. They have configured chorus as well. And now here what they're doing is they are doing the start WebSocket server. So they are wrapping the server Express server in a WebSocket. And there you will see that they are doing init server, and init server is where they define how to handle the connections. So they create a WebSocket server by wrapping in the server, and this is the handle connection method that is being called when the connection gets created. Now if we go in here in the handle connection, you will see that when the connection is created, what we also do is we figure out which models we want to use. Along with that, more or less, we also define what we want to do when a message is received. So if we go back in here and look at, so this is the type message. So when the message is received, so you can look at the type. This is the on message. So this is the message that is being received by the server. So what they want to do when a message is received, they want to handle the message, and they pass in the LLM that has been configured. They pass in the embedding model that they have configured, and you call in the handle message method. Now handle message is where we are handling a specific request or a chat message that the user has posted. Again, they create some sort of an ID that they will be using to store the chat. Along with that, you will see that what they try to figure out is they try to do the conversion of it to a WebSocket message. WS message has the message, it also has the optimization. So this is the same structure that we are looking at here: the type message, message, chat ID, focus mode, web search, optimization mode. So this is more or less the same structure that we have received here. And if we go back, so we get the past message. From the message we get this message, which is the message that the user has sent. From that, what we try to do is we first try to create the, or we first try to again extract the history from it. Now as you can see, there is a history array here as well, where they have specified the human has specified the better SQLite 3. So what they do is they just do a simple map over it, try to figure out whether the message is for the human or something else. If it is a human, it is a human message. They take the content and wrap it in a human message. This is coming from the LangChain. Now that becomes the chat history that you have. Now if the past message type is message, which is what we are handling right now, they try to figure out which handler has to handle it. Now search handler is a dictionary which has a reference to it. So it says that if the search mode is if the what mode, so if you look at what if the focus mode is web search, in our case web search, it has to do a handle web search. So what we are doing here is that we are calling the handler called the web search mode. Our handler here, if you look at it, the handle message that we have, if we go down here, the search handler, the handle web search is the handler that will be handling this request. Now if we go in here, you will see that what we are trying to do, we create an emitter, which is again the events will be emitted from it, the events that from the backend. when the LLM will generate the response, the token by token emission of the events will happen. This is what this emitter will do. And what we are doing is we are making a basic web search call. Again, all the same things are being passed through. The only thing that you will have to understand here is that there are two steps that happen here. The first thing that they are trying to do is they this is where they are trying to do the query rewriting. I have written a complete blog on query rewriting on my personal blog. So if you go to Shekhar Gulati query rewriting, so in all the LLM applications, at least the chat or the search applications, you will find that we end up doing query rewriting because users will type questions which are probably not questions. They might be just keyword, like we just use this keyword called better SQLite 3 or something else. And what we typically try to do is we try to generate a query that a LLM can answer. So what they are trying to do here is they are also trying to do a query rewriting here. And let's look at that. So that's the first step that they try to do in the basic web search answering chain, where you will see that they are saying basic web search retriever chain. And let's look at this chain. Again, this chain concept comes from the lang chain. So what they are trying to do is they are defining their prompt from this template. And if you look at it, this is the prompt we are talking about, where I said that they are doing query rewriting. So you are an AI question rephraser. So again, question rephrasing is part of the query rewriting. You are given a conversation and a follow-up question. So the history that we sent is being given along with the follow-up question. So better SQLite is part of the history. The next question was, I think, on the efficiency part of it, the question that we asked, which was here. So if I again go down, so we asked a follow-up question was, how does better SQLite 3 handle large data set? And in the history, we only had better SQLite 3. So you will have to rephrase the follow-up question so that it is a standalone question. Right now, because we used a follow-up question, which was a good question in itself, so there was a limited need for that. But if somebody does not type a proper query, then this step is very useful. Now, as you can see, they are also handling some sort of an edge cases. So if it is a simple, like if somebody just said hi, which is not a follow-up question, then what they are saying is that then you need to return not needed. So they're saying that the response in that case should be not needed as a response. This is because LLM won't need to search the web. So they're saying if somebody say hi, so if I just say hi here, you don't need to make a web search here. Hello, how I can assist you? Fine. So they are not making a call to SearxNG at this point of time. If the user asks some questions from some URL or wants to summarize a PDF, you need to return the links inside the links block, XML block, and the question inside the question block. So now they are specifying that the format in which they want to return the response. So as you go down, so if somebody says that, can you tell me what is X from this? X from this website. So they are saying that the question will be, can you tell me what is X? Again, this will be rephrased by LLM, or LLM might use some other language. But in the links tab, in the links XML tag, you will get example.com. So they are specifying how to handle queries where somebody specify a link. You must always return the rephrased questions at the question XML tag, which is this XML tag. If there are no links in the follow-up question, then don't insert links. So links should not, they're saying don't return empty links. There are several examples. So they have also given examples like, so again, as you can see, they are using XML structure to pass the metadata. And this is something which is very common. So if you read the Anthropic, I think prompt engineering guide, they also talk about sending the information in the structured format, and they also use XML. So like these are all the examples that they have shared. So it's always a good in prompt engineering. It is always good to pass the example so that LLM knows what to do and how to, in which format to return the response. So they have specified the examples. After that, what they have done, they have specified the conversation history. So this is the conversation history or the chat history, and then they have this is the follow-up question. Give us the rephrase question. If you have built any RAG application, you might have seen this kind of a structure. But again, it's good to see that any open source, popular open source product also does something similar. Now, this is the prompt that they're using. Now let's go back. So this is the prompt they pass to the LLM. In our case, the LLM is GPT. So if I look at the message here again, we are passing that we are using GPT 4o mini. So if you look at the URL here, in my case, I'm passing the GPT 4o mini as the model that I'm using. Again, model will play a big role in the quality of the result. So whichever model suits your need, you should use that, which gives you the best result and probably keep your cost low. Then they pass it to a string parser, which will convert that to a string. That's fine. After that, what they're saying is they're using a link output parser and a question output parser. Again, these come from LangChain. And what they do is they try to extract the links from it. They try to extract the question from it. So now after that, you have a links. If you are summarize, so let's assume that if I use, if I go to, where is my the perplexity app? So let me just close these and I open a new chat. So as you can see, whenever we open a new chat, it basically I think opens a new WebSocket connection. Now if I just say summarize the, extract the key lessons from the page. So let's assume if I give, and I'm passing in my blog, what it will do is it will first create a question, which is extract the key lessons from page, something like this, and the links will be the URL that I have typed. Fine. It will extract, download the content of this page, and then pass it to the LLM. And we will look at the code to understand it. But as you can see, at least on my machine, this application is slow. Yeah, so it is coming now. So key takeaways, importance of query writing, user intent understanding, strategies. So it basically picked up all the relevant things from my blog and generated that. And referring to the same blog multiple times. Right? So this you can't do in ChatGPT. So in ChatGPT, at least in the free tier, you might not be able to do that. Now, if again we go back to the code, you will, so what will happen is that for our example, which was extract the key lesson, so there will be one follow-up question it will generate based on the text that we have shared, and the links will contain the link that I have specified here. Now they are saying that if the question was not needed, which was if I could have specified only hi, where the response was not needed. So if the question is not needed, what they are doing is they're saying query is empty, docs is empty. We are just returning it from here because we don't want to make a search engine API call. If the link's dot length is greater than 0, fine, which is the example that I showed you. In this case, what they're trying to do is if there is no question, they just use the summarize as the fallback. Otherwise, what they do is they try to extract the HTML content of the page. Here, they are not doing anything interesting. What they are trying, they are just making Axios call. So they're just making HTTP call, get call, and just extract the HTML. From the HTML, they extract the text. I think that's what they're doing. So there is a library that they use. Let me just look at that. So you can see that this is the response Axios will give. They use a library called HTML to text, which you will see here, which takes in the HTML and give you the text. So that's what they're doing. They are replacing few things from it to clean it up. Then they use splitter is again a LangChain concept where for a long text they try to make it into small documents depending on your chunking strategy. So it is using recursive character text splitter. So it will be split, text will be split based on that, based on paragraphs. Then they also extract the title from the page, from the title HTML tag, and then they create some document they try to link. So maybe there are multiple links present, so they try to group these document uh, by those links. So that's what they are trying to do. Now going back to the agent. So now this is happening when our page has a link. Now what they're trying to do after that, if you look at it, is again we can go, they're just trying to group the links into some groups. After that, what they're trying to do is, now as you can see, this is where they're using something called a web search summarizer. So they're saying that you are a web search summarizer tasked with summarizing a piece of text retrieved from the web search. Fine. And there they are using the summarization capability, and they're specifying that if the query is summarized, you should provide a detailed summary of the text. They're specifying what tone it should use. It should be thorough and detailed. So they're specifying how the summary has to be. So example, they are saying text. Again, they are specifying that the response structure has to be XML. So they're saying the response has to be written in the XML tags along with the query. Uh, so they are saying that this is the text will be the, I think this is the context that they will be specifying. The text will be shared inside the text. So I think this is the context that they are passing. A query is the user query. So in our case, the query will be what are the key lessons from this page, something like that. And the response is the response that the LLM will generate. Below is the actual data. So this is how they specify. So this is the query that they have specified. This is the document page content, and the they just make sure to answer the query in a summary. Fine. So this is what happens if you use a if you want to extract information from a page, summarize a page. So that's the another mode that they support. So if I again, so the first we looked at, if question is not read, nothing needs to be done. So we just return query is empty, docs is empty, or an empty array. And this is what is happening, which is the else block is happening when we just asked about the better SQLite 3, where it has to do a web search call. So this is where they rely on this SearxNG. So as you can see, the question, which is the better SQLite 3, or the question will be, in our case, will be rephrased question that the LLM will generate because they first make a query writing. So this will be, this probably question could be, what are the features of SearxNG, or what is better SQLite 3? So something like that, a question will be there. And then what they're trying to do is they're trying to do a search in the SearxNG. Again, this is very simple. So they just make a HTTP call to SearxNG URL, which will be, in our case, it is running locally. They pass in a format JSON. They want response in a JSON format, and they pass in the query as query. So if I quickly show you, so it is running, I think, in localhost 4000. Yeah, yeah, something like this. And let me just say better SQLite 3, something like this. In our case, I think the question would be, what is better SQLite 3, something like this. They might have rephrased it to what is better SQLite 3. And this is where SearxNG is making a call. As you will see that the query is what is better SQLite 3. It gave the first URL, which is the URL of SQLite 3. And the content, as you can see, is not much. It is, I think, just the brief description that you get if you just do a Google search. So if I just do a what is better SQLite 3 on my Google browser, you will see that this is probably the what they are getting in there. So this is the only description probably that they are able to access. In most cases, if you are tempted, it is probably cannot be reasonable a compression SQL in general. They also specify what the thumbnail is, what the engine is, past URL part, past URLs, template engines. They're saying that in DuckDuckGo this is the first position, in Brave it is at 10th position, in Google it is at second position. They also give some score, published date if they know anything about it. Similarly, there's a Stack Overflow question, difference between SQLite 3 and better SQLite 3. I think, yeah, this is the same question that we are seeing here. This is the question that SearxNG also gave us. Again, depending on search engine, it also gives some rank. And I think it is trying to generate some score out of it. I don't know what the algorithm that they use to generate the score. And the highest result is shown at the top. The result with the highest score is shown at the top. They don't show number of results. I don't know why. Ideally, they should be able to do that, but I don't know why. So this is what they do. So we got this kind of a JSON structure, and as you can see, it gives you the result. It also gives you something called a suggestions as well. So if you go down, I think at the bottom you will see that it also gives better SQLite 3 electrons. So it also gives some suggestion as well. I think these are just like Google's suggestions that you get. I think better SQLite 3 versus SQLite 3 or something like these. Yeah, SQLite 3. So these are the suggestions it gives. I don't think it uses this Perplexica uses these suggestions, but again, SearxNG gives you that. Now going back here, so you got the results and the suggestions. They also specified language as English. So right now, this could be one limitation of SearxNG of Perplexica, that it only works on English results. Again, this could be parameterized and passed by the user as well. Now they convert these into documents. Again, I think documents are again the LangChain concept. What you need to do is you basically wrap it in extract the information from the result and convert it in a format that LangChain needs. And they also specify some metadata like the title, the URL, and a few other things. And they return the query and the document. So again, they are not doing anything with the suggestions. They only make use of the queries and the results. Now you will see, so this create basic web search retriever chain. This is what it does. So it first found the rewritten the question or rephrase the question, and it also find the links if there are any. If there are links, it takes a path where it has to summarize or extract information from that link. If it does not have any link, it is only a question. It makes a search engine query call to do that. So this is what we get from the create basic web search retriever chain, and it is being called from here in the same file. Now, as you can see, we will come to these later. Let's just look at what happens. So now let's go down. This is happening in the re-rank, and we will come to re-ranking a bit later. Now this is where this is what I think is interesting for us, because all of this is part of the re-ranking function that we've defined here. Now this is the query that was the rewritten query. Chat history we already have. In the context, it converts the chat history to a string. So that's a simple iterating over the chat history and picking up the content part from it. Then it does a basic web retriever chain. So again, this is where it basically first call the retrieval part. Then it pipes that to the re-rank docs. So whatever documents we have, it passes it to re-rank docs. This is the function that we have. Now this only works, I think, when this is again more or less what they're trying to do is it makes use of the optimization mode. So as we discussed earlier, the default optimization mode is speed. So there what they're trying to do is they're just trying to find the first 15 records of the results. So only they're picking up the first 15 results and returning it back. So they're not doing any re-ranking here. Now here it might happen that it gives them trouble because of the context issues, like the number of tokens limit that LLMs have. But again, because if we look at the content, you will see that it's not that big. The content that is being passed is these are content. So 15 such strings are appended, and this is becoming the context of it. So it should not cause any issue. But if the optimization mode was balanced, which is the second optimization mode, they what they're trying to do is they're trying to do the they embed the query, they embed the document, they re-rank the document in context of the query. So they try to compute the similarity between the query and the document. So you have 15 results, or all the results that you fetched from the web search. You're trying to see, depending, you're trying to compare the content with the question that is being asked. And then I think they also pick up the 15. So as you can see, similarity has to be greater than 0.3. They pick up the 15, top 15 records. And in this case, the response could be different if the first 15 records had low quality results. So they do have some quality re-ranking built in, but it's very primitive. Uh, so that's what they're doing, and it will be slower. So when you choose the mode as balanced, it will be slower because it has to first make these calls to the language model to embed these, and then it has to compute the cosine similarity and then do the comparison. So it will take more time. I think that is fine. So once the documents are re-ranked, in our case, because we were using the mode as speed, there was no re-ranking happening. But in case re-ranking happened, the ordering of the documents could be different. And finally, it goes to the process document again, where they process some aspects of it. And so that is the one chain that they call. The second, after that, what they do is they basically are making a basic web search response, and this is where they are doing the generation. So now this is the second prompt that we are looking at. This is where what they're doing is they are trying to generate the answer from the content that they have pulled in from the web search. So here, as you can look at the prompt, system prompt of it, they are specifying that you are Perplexica AI model search who is expert at searching the web and answering user queries and all that. Generate a response that is informative and relevant to the user query based on the provided context. You must use this context to answer the query. Use an unbiased tone. You must not tell the user to open any link. You must provide the answer in the response itself the user asks. So they're saying that rather than saying the answer is here, you should provide the answer. If the query contains the link and user asked to answer from those links, you will be provided with the entire content in the context. You can use this content to answer the user query. If the user asks to summarize, so they have specified all the instructions that they need. They've also specified how to do the citation. So you can look at, you have to cite in number notation. You must cite sentences with the relevant context number. You must cite each and every part of the answer. So again, everything about citation is part of the prompt, and they have also helped the it by specifying how to generate the citation, how to generate multiple citations. So it's part of the prompt. However, you do not need to cite it using the same number. You can use a different number to cite the same sentence multiple times. The number refers to the number of the search result. So again, the where the number of the search result is. Anything inside the context HTML block below is for your knowledge returned by the search engine. So this is what they're specifying in the context, and they're also specifying if you can't answer the query from the context, I tell it that I can't find the information. So they've also again handled that scenario, and they also specified the today's date, which could be useful in case the query has some temporal nature. Like if I say, just to quickly show you an example, if I open a new and I say, what is today's date? So they made a call to LLM to find out, and it said it's 14th October to do that. And if I say how many days to Christmas, so date sometimes helps you in that when you're trying to generate the answer. Fine. Now, so this is the prompt which is generating the response. Again, nothing magical here. Now going back to the place where we were. So this is where we generate the answer, and we return back to the create basic web search. This is where we did a basic web search. Then that's where how they're handling the streaming. So in the chain, again, this is provided by LangChain, so they're streaming the events that are coming, uh, and the stream is part of the handle stream method, which handles the stream, which will be, if you look at it, it will be calling the WebSocket like emitter.emit and making those mess or pushing those messages to the client. These are the data messages, fine. So more or less, this is what it does. Again, I think it's not that complicated to understand what they're trying to do. Uh, and one more thing that you will notice is that there are other agents. So web search agent is just one agent. There are other agents as well. But what you will notice is that the flow is more or less the same. So if I look at the academic search agent, they have how to do the query rewriting, more or less the same. So they're saying follow-up question, what is the refresh question? They're specifying. Then the second is how they want to generate the response. This is the response prompt, more or less the same. They're passing in the content, they're specifying how to handle the query, what they can do, what if they can't handle the query. Now here the engines are different. So they are passing in the search SearxNG, they are saying archive, Google Scholar, and PubMed is the engine that they are using. In the web search engine, if I just show you in the web search agent, they were saying they were not specifying any engine, so it was all, I think, Google, DuckDuckGo, and Bing probably were there. Here they're specifying that they're interested in the archive, Google Scholar, and PubMed as the engine. So the results will be only coming from that. So just to quickly show you that, if I use the academic mode and I say impact of large language models, or let me specify large language models on software engineering. Now, right now we are using the academic one, so it will be searching archive, PubMed, and Google Scholar. So now, as you can see, the links are different, both from the academic world, and the response generated will be on those lines because the context is coming from there. And after that, again, this is the similar thing. They do a map over the results, build the documents, and as you can see here also, they're doing some, it's more or less the same code. This re-ranking code is also the same. So speed, slice 15, balance to the embedding, compare the embeddings corresponding to the embedding of the query. This is again the same code. You will see re-ranking. Finally, they pass it to the answer generator prompt, and which is more or less the same as we did. And you will find all of them are more or less same. Reddit search engine is also same. There are two prompts, main prompts that they have, which is query writing and the response generation prompt. Just the engine changes. So here, as you will see, that in the SearxNG, the engine is Reddit. In the Wolfram Alpha search agent, the engine is Wolfram. That is what it will be happening. Yeah? So you will see that SearxNG, you will just go down, yeah, you will see the same thing, and the flow is more or less the same. So it's not a complicated code base to look at. I hope you find it useful. I found it useful in the work that I am doing. I also end up doing something similar, so it helps me to understand how a popular open source project is using it. Thanks a lot for your time.